In this video, I'm going to talk about electric circuits and try to draw an analogy between circuit elements, electric circuit elements, and elements in a building. And I'm going to use Loyola Hall as an example here. So on the right-hand side, this is my rendition of Loyola Hall. What you see here on the left-hand side is an elevator shaft. So I'll put E here for the elevator shaft. And in the elevator shaft, you have a teacher or student here that's going to go up to the second or third floor. And let's say this student here. Now, in real life, you can't do this. If this is a handicap access only for teachers, so if you do that, you might get jugged. But let's say you go over here and you go to the third floor. Okay. You go to class, and after the bell rings, you go down the stairs. Let's choose these set of stairs to go through. You come back down here to the ground floor. I'll call this the ground floor. G and D. This is the second floor, and this is the third floor. Okay. And a different day, you might go up the elevator and then maybe go down the second set of stairs. So you have a second path to ground, back to the elevator. So there's two possible paths. Now in reality, there are many, many students. So I've drawn one student here, but in reality, there's many students going down either set of stairs, and they're probably going to use a set of stairs that are the least crowded, or the one that's closest to their class. But at any rate, they can always go back to ground. There are two paths to ground here, and the elevator gives them energy. We call it energy, potential energy, and they're gonna lose energy on the way down. This is very similar to what happens in a circuit. In a circuit, you have a ground level. That's why they call it electrical ground, G and D. That's where there's zero energy. Zero, and the unit for energy is a joule. I use a J here for joule. There's zero energy here. So in an electrical circuit, we don't have students. We have electric charge. This is an electrical charge here. So moving charges is what really electricity really is, just like moving students. Now, the electric charge here is at the ground level. In order to get energy, the elevator, it needs an elevator. It needs a battery. So the battery is like the elevator, and they can go through the battery and gain energy. So here's Mr. Charge. So first thing here, electric charge is like the student, the battery is like the elevator. Now, as you know, there are different voltage batteries. There's 1.5 volt batteries, 9 volt batteries, and whatnot. So the voltage is kind of like the speed of the elevator. If you have an elevator that's very fast, it can bring up students at a very high rate, and there's many more students that can come down the stairs. That's what the voltage rating is. So if you have a 9 volt battery, it gets them there quicker and increases the flow of charge. Electric charge really, when you get down to it, are electrons. They are moving electrons. Now, one unit of charge is called a coulomb, 1 coulomb. But it really is a collection of electrons, and it's 6.24 times 10 to the 18th electrons. So that's a lot of electrons moving around. So we usually don't talk about electrons individually. We just say coulombs of charge, a collection of them moving around. It's very similar to a student. We talk about a student moving around. We don't talk about individual atoms or molecules that make up the student moving around. We talk about a student. So we talk about a coulomb of charge. So that's number 2. In our building, the floors here, or the height, is the electric potential energy. So as students go up, they gain energy. It's actually gravitational potential energy because it's against the pull of gravity. Here, it's electric potential. So these charges gain energy by going through the battery, just as an elevator gives students energy. And then finally, the last thing are the stairs. Stairs are like the resistors. And in our lab, these have been like light bulbs. They could be a heating element to generate some heat, like a heater, maybe a speaker to generate sound. So in our building here, the stairs are where we lose energy. In a circuit, when these coulombs of charge go through a resistor, they can give off heat, light, or sound. So this Mr. Charge comes down here, comes back to the ground level, and then completes his loop over here like this. And then just like the building, you could have multiple paths to ground. So this is a separate path to ground. And again, I've drawn 1 coulomb of charge here. There are many, 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 many coulombs of charge traveling around the circuit, going through the battery, gaining energy, and the higher the voltage, the faster they go, and there's more coulombs of charge moving throughout the circuit. So there's an analogy you can draw between an electric circuit and students traveling through Loyola Hall. Elevators are like batteries. The voltage is the speed at which the elevator moves. Students go and gain energy and then come down the stairs. Coulombs do the same thing. They start at the ground level. That's why it's called electrical ground. Go through a battery to gain energy, the higher voltage the battery, the higher the speed they go through here. It increases the flow of charge. And when they move through resistors, they can give off heat, light, or sound. Or they can be motors and they can move. So those are your simple analogy for electric circuit and students moving through Loyola Hall.